How does tool geometry affect machining performance? Imagine shaping a piece of metal or plastic with a tool that feels just right. The way that tool is designed can change everything about how well the job turns out. Tool geometry is all about the shape, angles, and size of the cutting tool. It influences how much force is needed to cut, how fast the process is, and how smooth the final surface looks. When you understand how these features work, you can pick the best tool for each job. Let's start with the rake angle. This is the angle between the face of the tool that cuts and the surface of the material. A positive rake angle makes cutting easier because it reduces the force needed and helps chips flow away smoothly. This means less heat and less wear on the tool. But if the rake angle is too positive, the edge can become weak and break more easily. On the other hand, a negative rake angle makes the edge stronger, which is good for harder materials. But it also increases the force needed and can cause rougher surfaces because of more vibration. Next is the clearance angle. This is the angle that keeps the tool's flank from rubbing against the material. Proper clearance reduces friction and heat, which helps the tool last longer. If the clearance is too small, the tool can get hot quickly and wear out faster. It can also cause scratches or damage to the workpiece. The nose radius, or the size of the rounded tip of the tool, also matters. A larger nose radius gives a better surface finish because it makes the cut smoother and reduces marks left by the tool. But if it's too big, it can increase the cutting forces and cause the tool to bend or deflect. That can affect the accuracy of the part. Chip breaker design is another key factor. These are features built into the tool to control how chips break off. Proper chip breakers help break the chips into smaller pieces, preventing them from tangling or damaging the tool or workpiece. This keeps the machining process stable and helps the tool last longer. Tool stability and deflection are also influenced by geometry. A well-designed tool distributes the cutting forces evenly, reducing bending or displacement. This is important for maintaining precise dimensions and a good surface finish. Finally, the shape of the cutting edge and the edge's sharpness affect how long the tool lasts. Tools with honed or chamfered edges can resist wear better because stresses are spread out more evenly. This means the tool stays sharp longer and performs consistently. In practical terms, choosing a tool with a positive rake angle and proper clearance is great for softer materials like aluminum. For harder materials like steel or titanium, a negative rake angle and stronger edges are better. Using a larger nose radius in finishing cuts improves surface quality but needs balancing with the forces involved. Chip breakers are essential in turning operations to keep chips manageable and prevent damage. Understanding how tool geometry affects machining helps you pick the right tool for each task. It improves efficiency, reduces costs, and makes sure the finished product looks and works just right. When you match the tool's shape and angles to the material and process, you get better results every time.